Welcome to another session on this Mathematics 2. The topic is, in this one, we are going to discuss direct methods to solve the linear systems. In that one, as per the syllabus, it is given clearly only Gauss elimination method, but for our knowledge purpose, we'll study both the Gauss elimination method as well as Gauss Jordan's method. Both we'll discuss here. Only a small difference in between. Let us see that. So, in the Gauss, wherever the Gauss method we have, Gauss method takes only elementary row operations. That's the thing we need to remember that. Gauss method take only elementary row operations. Whether it is Gauss elimination or Gauss Jordan. Then what's the major difference here? It is suppose here Gauss elimination. If I go, the output will be echelon form. I need to try for only echelon form. If I go with Gauss Jordan's, if I go with the Gauss-Jordan's method, the output will be multiplicative identity. That's only the major difference in between. So, for one problem, we'll discuss both the things here. Let me open that. Here, the same logic. Here also, I may work with only augmented matrix here. A and last column, the representation, it may vary from the other to other. I consider here as C equals to A, and last column I'm appending to the coefficient matrix. Means the constant matrix appended as a last column to the existing coefficient matrix. Then on this I'm working here. So what I'm trying to do is here I'm reducing this to upper triangular matrix or echelon form. Simply echelon form. Remember that, echelon form. Then using only elementary row transformations only, row operations or row transformations, and then using the back substitution method, will use this. And here also, as already we discussed, direct methods, the major drawback of the direct methods is, even though if the system holding infinitely many solutions, it may get only unique solution. So here using elementary row transformations and then back substitution, as we studied in earlier, since it is a direct method, we may get, though the system holding the infinitely many solutions, we can able to extract unique solution. So we need to keep that point in our mind. I think in the last session we discussed that, we gave that point clearly. Now here same, the equation is x plus y plus z equal to 8, 2x plus 3y plus 2z equal to 19, 4x plus 2y plus 3z equal to 23. Then augmented matrix is this is the coefficient matrix and this is a constant matrix. Now what I need to do is by using this, elements below this must be 0 in the first step, and the second step by using this, this position, elements below the must be 0, by using this, elements below the must be 0 if exists. Since it is not there any other element, so within two steps we can wind up the problem. So let us see that here. Now here I need to update, I need to modify to row 2 as zeros here 2. So if I multiply the row 1 with 2 and then subtract from here, we may get it. That's the reason here r2 minus 2 r1 we wrote, and the second here 4, here is 1. So multiplying the first row with 4 and then subtract from the row 3. So at the end of the first step, this is the equation I'm getting here. Still, those are not clear about this. For your clarification, let me write on this. R2 I need to dump first. R2 is 2, 3, 2, 19, 2 R1. Multiplying the row 1 with 2. So here 2, 2, 2, 8 2s are 16, and subtract minus minus, because minus is there. Change the sign, I mean to say that. So I may get here 0, 3 minus 2 1, 2 minus 2 0, 19 minus 16 is 3. That's what we are getting here. Means those who are not able to understand directly, this is the one way to get it clear. Similarly, R3, if I write the R3, 4 2 3 23, and 4 times R1, 4 4 4, 4 8s are 32, and here subtraction, negative 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 negative. So this would be 0. 2 minus 4 is minus 2, 3 minus 4 is minus 1, 2 minus 3 is minus 1, 3 minus, sorry, small mistake here. 23 minus 3 minus 4 is minus 1, 23 minus 32 here, minus 9. That's what. So we'll get this one. Hope it's clear now. So the elements below this are 0, then the control will jump from here to here. Now the elements below the second element, it must be 0. So for that reason, here is minus 2. If I multiply this row with 2 and then add, because it's in the subtraction, and so multiplying with the 2 and adding that, we may get it. So R3 plus 2R2. So R3 is 0 minus 2 minus 1 minus 9. Second row I'm going to multiply with the 2. 0 2 0 6, adding, so no need to change any sign. 0 0 minus 1 0 minus 1 minus 9 plus 6 will be minus 3. So I'll get, this is the value. Hope it's clear. Then once it is up to the coefficient matrix, once it is reduced to upper triangular matrix, then by using back substitution method, I need to try the back substitution method here. Using this, z minus z equals to minus 3, then implies z value would be 3. We got it from here, it's fixed. Now moving a little up here, 0x plus y plus 0z equal to 3 means simply y equal to 3 directly. Fortunately it is getting clear. So y equal to 3, and then moving one more step, even this also completed. So x plus y plus z equal to 8, then x plus y value is 3, z value is 3. That makes here x equals to 8 minus 6 will be 2. That's what. So I make it, the solution is 2 3 3. What's the guarantee that it is a right or wrong? Just substitute these values in any one of the equation. For example, if I take a second equation, 2 3 3, 2 2s are 4, 3 3s are 9, 2 3s are 6. So 4 plus 6 10, 10 10 plus 9 19. So we got it. This is by Gauss elimination method. Now if I, for the same problem, I may try even Gauss-Jordan's method also. Now let us check one more here. 3x plus y plus 2z equal to 3, 2x minus 3y minus z equals to minus 3, x plus 2y plus z equal to 4. So the coefficient matrix is 3 1 2, 2 minus 3 minus 1, 1 2 1, and the constant matrix 3 minus 3 4. That's what. Now let us try this one by using Gauss-Jordan method. So by Gauss-Jordan method, I may try like this. Here the augmented matrix I am writing. Generally I denoted that with C equals to 3 1 2 3, 2 minus 3 minus 1 minus 3, 1 2 1 4. This is the augmented matrix. Now what I need to do is, by using the first principal diagonal elements below and above, if exist, below and above there is no element is exists above, so means I need to update only row 2 and row 3. So row 2 primes with help of row 1, row 3 primes row 3 with help of row 1. If encircle, it will be easy for you to fix here. So here is 3, here is 2, here is 3. So since both are relatively prime, I need to interchange the coefficient. So R2 multiplied with 3, R3, R1 multiplied with 2, and then since both are having the same sign, so I need to subtract, means minus. Similarly here, R3 is updated is 1 and 3. So third row multiplied with 3 and subtract R1 from R3, 3R3. So for your convenience, here I am not updating anything to the row 1. So row 1 would be same 3, 1, 2, 3. We made these two 0 anyhow by using that method for our convenience. 3R2. So 3 2s are 6, minus 9, minus 3, minus 9. 2R1, 6, 2, 4, 6. Change the sign. So I make it 0, minus 9, minus 2, minus 11, minus 7, minus 15. So the second row would be 0, minus 11, minus 7, minus 15. Similarly, 3R3 minus R1. So multiplying the third row with the 3. So I'll get here. Let me change the color so that we may find differences here. So 3R3 means 3, 6, 3, 12. R1, 3, 1, 2, 3, minus. So change the sign. I make it here 0, 5, 1, 9. So I make it here. Fourth one is 0, 5, 1, 9. So here, whenever I'm using this Gauss methods, we need to write the equivalent sign here. Similarly, now the control jump from here to here. Now the control will jump from here to here. Now above and below, R1 I need to update, and now I need to update row 1 and row 5. Sorry, row 1 and row 3. Row 1 updated here. Row 1 based on row 2. Row 3 based on row 2 again. Now what the possibilities? Let me check here. Here, based on this, here is minus 11. If I get 11 here, so 11 R1 plus it will be. So here it is 5. Here is negative 11. Since both are relatively prime, I need to interchange the coefficient. So R3 multiplied with 11, R2 multiplied with 5. Since both are alternative signs, then plus I supposed to. So here I updated only R1 and R3. So R2 will be as it is 0, negative 11, negative 7, negative 15. And as per that 11 R1. So will be 33, 11, 22, 33. And R2 0, negative 11, negative 7, negative 15. Then if I simplify here, 33 will be 0. Here, do I made any mistake? Okay, first one. And 22 minus 7 will be 15. 33 minus 15 will be 18. So the second row, the first row would be 33, 0, 15, 18. And third row is 11 times R3. So 0, let me change the color to get clarity. Third row is 0, 5, 1, 9. So I need to multiply with 11. 0, 55, 11, 99. 5 R2. Multiplying the second row with 5. 0, negative 55, minus 35, negative 75. So this already 0, this already 0. Now minus 35 plus 11 will be minus 24. Here minus 75 plus 99 will be plus 24. So the values would be 0, minus 24, sorry 0, 0, that's my mistake, 0, 0, negative 24, positive 24. In Gauss elimination or Gauss-Jordan's method, or wherever Gauss method, I am writing this equivalent sign. Now, before proceeding from here to here, let me divide, or I would like to simplify this one. So, R1 I can divide with 3, R1 primes, R1 divided by 3, R2 is not possible for the simplification, R3 primes, R3 divided by negative 24. Then I may get here equivalent signs. 33 divided by 3 is 11, 0, 5, 6, 0, negative 11, negative 7, negative 15, 0, 0, 1, negative 1. Now the control is jump from first from here to here. I jumped, means above and below are completed. Next I need to jump from here to here. Now in this stage I need to update R1 and R2. So the operations would be R1 with help of R1 and R3, R2 with help of R2 and R3. See, here is 1, R1, R3 is 1. So if I multiply R3 with 5, R3 with 5, since both are having the same sign, I need to subtract. So here also R2 is negative 7, multiply R3 with 7 and add it. So here I am updating only R1, R2. So R3 will be as it is, 0, 0, 1, minus 1. For our convenience, this we made 0, this we made 0, these two we made 0 wantedly. Means with that want the convenience is only two values I supposed to compute. Those two values are here. R1 minus 5 R3. R1 is 11, 11 minus 0 is 11. Here 6 plus 5, 11. And the R2 plus 7 R3 minus 11. Here R2 is minus 15 minus 7. Minus 15 minus 7 will be minus 22. That's one. Now clearly it is in the form of diagonal matrix up to the here, yeah, up to this it is a diagonal matrix. Once the coefficient matrix is diagonal matrix, means only the part left to us is the principal diagonal position should be 1. So that reason R1 primes R1 by 11, R2 primes R2 by negative 11, R3 already it's 1, so no need to disturb that. We'll get here 1, 0, 0, 1, 0, 1, 0, 2, 0, 0, 1, negative 1. So in the last position, whatever that we have, this is 1, 2, minus 1. This will be taken as x, y and z. So this is the value of x, this is the value of y, this is the value of z. So therefore the solution is x equals to 1, 2, minus 1. That's what the solution. Hope you connected to this. So these are some exercise problems to complete this. Test the consistency. The question might be asked like this. For earlier, test the consistency of the non-homogeneous system of linear equations. How do you say that it is non-linear? Because here here is a variable, here is a variable, here is the variable, degree 1, but here there is no variable, so it is degree 0, it's degree 0, it's degree 0. So if the constant is available means that is a non-homogeneous. So all these are the non-homogeneous systems. So phi, and here we tried earlier this A and B in place of lambda and mu, here A and B. So you please try these problems, and here Gauss elimination method, and the Gauss elimination method here, and the Gauss elimination method, as we discussed, the final matrix should be a triangular matrix. Clearly speaking, upper triangular matrix or echelon form, upper triangular matrix. And in Gauss-Jordan method, this is multiplicative identity. Multiplicative identity. So this is Gauss-Seidel is not there in your syllabus, so that's the reason I'm not discussing this method. Earlier syllabus it was there. So hope you are with that non-homogeneous solutions completed. Then I wantedly a plan to discuss the consistency of the homogeneous system is last, because its extension I may move to the eigenvalues. For that reason, how to I'm switching this to the eigenvalues we may discuss in the next session. So take care and please practice these set of problems.